Hello netizens of the world, and welcome back to my channel. And for today's video, I'll be showing you how to integrate powers and products of sine and cosine functions of the form integral of sine raised to m of u du, integral of cosine raised to n of u du, and integral of sine raised to m of u times cosine raised to n of u du, where m or n element of positive integer. Okay, at the end of this video, I'll be showing you how to integrate such functions in the shortcut and or in the easiest possible way. Okay, for this group of integrals, we have to recall that the derivative of sine x is equal to cosine x dx. The derivative of cosine x is equal to negative sine x dx. Also, for this group of integral, the most important trigonometric identities that we are going to utilize is the square identity, cosine squared x plus sine squared x equals 1. For m or n, odd integers, and for m or n is an even integer, then we will be using cosine squared x equals 1/2 plus 1/2 cosine of 2x, and sine squared x equals 1/2 minus 1/2 cosine of 2x. Okay, so I think we're all set, and let's have some example. Say we wish to integrate integral of sine raised to 5 of x cosine raised to 4 of x dx. Again, we wish to integrate, or we wish to find the integral of sine raised to 5 of x cosine raised to 4 of x dx. Okay, so for this example, m being the power of sine is equal to 5, which is odd, and n is equal to 4, which is an even integer. Okay, so what we only need to consider are the powers of your sine and cosine functions. Again, at this case, m is equal to 5, which is an odd integer, and n is equal to 4, which is an even integer. Okay, so we will be considering an odd power. And for this case, if the power of sine, which is m, is an odd integer, then we will be factoring out sine x dx and change the remaining sign into cosine. So we have integral of, so we will be writing sine x along with dx, and then originally you have here sine raised to 5, so I will write sine raised to 4 of x. So this 2 makes sine raised to 5, and then I will just copy this cosine to the 4. Okay, so do not forget that sine x, okay, has something to do with the derivative of your cosine. Again, the derivative of cosine x is negative sine x dx. So, technically, what I'm going to do with sine to the 4x cosine to the 4x is I will rewrite all of this in terms of cosine by using this identity. For sine to the 4x, say we have 1 minus cosine squared x. 1 minus cosine squared x by using this identity is equal to sine squared x. And originally, we have sine to the 4. So I need to raise this to the second power. Okay. And once again, I will copy cosine to the 4x and sine x dx. So what do you notice on this integral is that aside from this sine x, you notice that everything is now written in terms of cosine, and we can now assume or let u be equal to cosine x, and its derivative is negative sine x dx. Obviously, this is only sine x dx, so we need to avoid this minus 1 by multiplying negative 1 on both sides. So we leading us with negative du is positive sine x dx. Okay, so we now have our u and we now have our du, so we are now ready to replace this in terms of u. So we now have integral of 1 minus cosine squared x is 1 minus u square, then square, and then cosine to the 4 is your u to the 4, and then sine x dx is your negative du. Okay? So what comes next is to manipulate this algebraically. So by first, we need to expand 1 minus u square square. So we have square of the first minus twice the product of the first and the second plus square of the second. So we have 1 minus 2u square plus u to the 4 times u to the 4 and then du. So the next step is to introduce u to the 4 each term inside the parentheses, leading us with integral of u to the 4 times 1 is u to the 4 minus 2u to the 6 plus u to the 8 du. So the only thing left is to integrate u to the 4 minus 2u to the 6 plus u to the 8 du. So this time we will be using the power formula for the integral of u to the n du, which is equal to u to the n plus 1 over n plus 1 plus c. Okay? That's it, sorry. Okay, so we are now ready to integrate. Integral of u to the 4 du is u to the 4 plus 1 over 4 plus 1, that's 5, minus 2u to the 6 plus 1 over 6 plus 1, that's 7, plus u to the 8 plus 1 over 8 plus 1, that's 9, and then you add c at the end. Okay, so what are we going to do next is to introduce this negative 1 each term here, and then afterwards we are going to replace u by cosine x. Okay, so we now have negative 1 over 5, u to the 5 will become cosine to the 5 x, then negative 2 over 7 multiplied by negative 1 will become positive 2 over 7 cosine to the 7 x, then positive 1 over 9 times negative 1 will become negative 1 over 9 cosine to the 9x plus c. Okay, so we now have the integral of sine raised to 5 of x times cosine raised to 4 of x dx is equal to negative 1 over 5 cosine raised to 5 of x plus 2 over 7 cosine raised to 7x minus 1 over 9 cosine raised to 9 of x plus c. Okay, so if one might ask, is there any possible way to do the integral of sine and cosine functions the easiest way or the shortcut method? Okay, so let's do it in the easiest possible way or the shortcut way. So again, I will first rewrite our given, which is integral of sine raised to 5 of x and then cosine to the 4x dx. Okay, so to do this, we need to identify again our powers. So m is equal to 5 and n is equal to 4. So this is an odd power and this is an even power. So in this case, we will only be considering the odd power. So that is 5, the power of sine. And we have to take note that the integral of sine x dx is equal to negative cosine x. So this time, we will be using the power of cosine along with the minus sign in front. Okay? So we write negative 1 and then the open parenthesis. And then inside the parenthesis will be the series of cosine function. Okay? Okay. So for the how many terms, if you might ask, how many terms are we going to consider? So again, you go back here. So this is 5. So that's m minus 1 all over 2, which is equal to 5 minus 1 all over 2, which is equal to 2. That's 5 minus 1 is 4, divided by 2 is 2. So in this case, we can now apply the principle of Pascal's triangle. Okay? I will first draw the Pascal's triangle starting with 1. By the way, the Pascal's triangle is used for binomial expansion. So the Pascal's triangle basically will identify the coefficient of each term in the binomial expansion. Okay, so 1, the next term in the series will become 1, and then 1 plus 1 is 2, and then at the corner is 1, and then we continue 1, 1 plus 2 is 3, 2 plus 1 is 3, and then 1 at the end. Okay, so technically this will be your a plus b to the 0, then this is your a plus b to the 1, and a plus b to the second power, and then a plus b to the third power. Again, you go back here. This is m minus 1 all over 2, which is equal to 5 minus 1 over 2, which is equal to 2. So we might consider this series of coefficients 1, 2, 1. And then we take note of the sign, alternating sign, starting from plus, minus, and then plus again. Okay? Let's write the power of cosine here. So I'll start with 1 cosine of x, then minus 2 cosine of x, then plus 1 again, plus 1 cosine of x, close parenthesis, and then plus c. Do not forget to write c at the end. Okay, for the powers of this cosine function, again, you add m plus n. So we have m plus n, which is equal to 5, plus 4, which is equal to 9, and this will identify the powers of your cosine function. So basically, we are going to consider all the odd integers less than or equal to 9. So we only have 3 terms here. So we will be having 9, 7, and 5. Okay, let's get it on. Again, that's 9, 7, and 5. And we will start at the right side. Okay, so we have 9 cosine to the 9 over 9. And then we have here 9, 7 over 7. We only consider all the odd integers less than or equal to 9. And then 7. The next is 5 over 5. And then we now have negative cosine raised to 5x over 5 minus 2 over 7 cosine raised to 7x plus cosine raised to 9x over 9 plus c. So what I only need to do is to introduce this minus sign. So I will now have negative 1 over 5 cosine to the 5x plus 2 over 7 cosine to the 7x minus 1 over 9 cosine to the 9x plus c. And by shortcut method, we have arrived at this function. Okay, so to verify, so this is our long method. And then earlier, we have provided this by using our long method. Okay, so we compare negative 1 over 5 cosine raised to 5x plus 2 over 7 cosine raised to 7x minus 1 over 9 cosine to the 9 of x plus c. Once more, negative 1 over 5 cosine raised to 5x, that's similar, plus 2 over 7 cosine raised to 7x minus 1 over 9 cosine raised to 9 of x plus c. Okay, so we take another example. So this time, we will work on the power of cosine function. So let's have, say, integral of cosine to the 7 of 2x times sine square of 2x dx. Again, we will be integrating cosine raised to 7 2x times sine squared 2x dx. So we identify the powers of your sine and cosine function. So sorry for that. We have m power of sine is equal to 2, which is an even power. And then that's n. That's n, which is equal to 7, which is add. Okay, so again, we will work on the add power. So cosine raised to 7 2x. So in this case, we will now be factoring out cosine 2x. And I will write it beside dx. So I now have cosine 2x dx. Again, originally, I have cosine raised to 7 2x. So I will write cosine raised to 6 2x. So this makes cosine to the 7 2x. And then I will just copy sine squared 2x. Sine squared 2x. Okay, so our new integrand is now equal to cosine raised to 6 2x, sine squared 2x, cosine 2x dx. Okay, again, do not forget that this cosine 2x is the derivative of your sine x. Once more, we have to recall that the derivative of sine x is equal to cosine x dx. So, which means I need to rewrite everything here in terms of sine. So this is already in sine function. So this cosine raised to 6 2x will be written in terms of sine by using the square identity cosine squared x plus sine squared x equals 1. Okay? So we have 1 minus sine squared 2x. Again, this is your cosine squared. Raise it to the third power to make it 6. And then copy again sine squared 2x. Copy cosine 2x dx. So again, what did you notice is that everything here is now written in terms of sine. And again, the derivative of sine is your cosine. So we can now let u be equal to sine 2x. Okay? And then its du is equal to cosine 2x, then 2 dx. So technically, we only have cosine 2x dx here. So you need to avoid this 2 by multiplying 1/2 in each side of the equation, leaving us with 1/2 du is equal to cosine 2x dx. Again, so we now have our u, which is equal to sine 2x, 1/2 du, which is equal to cosine 2x dx. So we are now ready to replace everything on our integrand. So we have integral of 1 minus sine squared 2x is written as 1 minus u square cube. And then sine squared 2x is your u square. And then cosine 2x is your 1/2 du. And then, just like what we did earlier, we are going to expand 1 minus u square cube. So we have 1/2 integral of 1 minus cube of the first, okay, minus thrice the product of the square of the first and the second. So 1 square is 1 times u square is u squared times 3. 3u square plus thrice the product of the first and the square of the second. The square of u square is u to the 4 times 1, then multiply it by 3. 3u to the 4. And then, the last term would be cube of the second. Cube of u square is u to the 6. So, minus u to the 6 times u square du. Then, the next step, again, is to introduce u square each term in the parenthesis. So, we have 1/2 integral of u square minus 3u to the 4 plus 3u to the 6 minus u to the 8 du. And again, by using power formula for the integral of u raised to n du, which is equal to u raised to n plus 1 over n plus 1 plus c, where n is obviously not equal to -1, then we are now ready to integrate this expression inside the parenthesis. So we have 1/2, do not forget to copy that 1/2, times u 2 plus 1 over 2 plus 1, so that's u cubed over 3, minus 3u to the 5 over 5, then plus 3u to the 7 over 7, minus u to the 9 over 9, and then again, do not forget to write c at the end. Okay? And then finally, we only need to introduce 1/2 each term here, and then replace u by sine 2x. Okay, so finally, we have 1 over 6 sine cube 2x minus 3 over 10 sine to the 5 2x plus 3 over 14 sine to the 7 2x, then minus 1 over 18, that's 9 times 2, okay? Then sine to the 9 of 2x plus c. So we have the integral of cosine raised to 7 2x times sine squared 2x dx is equal to 1/6 sine cubed 2x minus 3 over 16, or sorry, that's 3 over 10, it's 10. 3 over 10 sine to the 5 2x plus 3 over 14 sine to the 7 2x minus 1 over 18 sine raised to 9 2x plus c. Okay, so once more, we are going to do this again by using the shortcut method. So we have integral of cosine to the 7 2x sine square 2x dx. So again, we will only be considering the odd power for n, which is equal to 7. Okay? So since n, 7, is the power of your cosine, and we know that the integral of cosine 2x dx is equal to 1/2 sine of 2x. Okay? Then you may not plus c. So, but this time we will only be considering 1/2 2x equals. So again, so 2x, so we have 1/2 in front, okay, then draw a parenthesis. So for the number of terms, we will be applying the same technique. We will be using the Pascal's triangle again. Pascal's triangles will be 1, 1, 1, 2, 1. Okay, so this is your to the 0, to the first power, to the second power, to the third power, and to the fourth power. Okay, so we will now identify how many terms and which entry on this triangle are we going to utilize. Again, you consider n equals 7, so we have n minus 1 all over 2, which is equal to 7 minus 1 all over 2, which is equal to 3. So for in this case, we will be utilizing 1, 3, 3, 1, and then the sign is alternating plus, minus, plus, minus, plus 1 minus 3 plus 3 minus 1. Okay, so again, we write the power of your sine function. We have sine 2x 1, then minus 3, sine 2x, and then plus 3, sine 2x, okay, and then we continue, plus minus 1, minus 1, sine 2x, close parenthesis, and then you add c at the end, okay. First, let's see. Okay, there you have it. So, for the powers of your series of sine inside the parenthesis, first, you add 7. So, that's m plus n again. So, that's m plus n, which is equal to 2 plus 7, which is equal to 9. So, again, we'll start at 9. And then we use all the add integers less than or equal to 9. But we will start at the right side. So, let's start putting the powers for each of this sign. So let's start at 9 over 9. Then the next add integer would be 7. 7 over 7. And then the next will be 5 over 5. And then the last add integer would be 3 over 3. Okay? And then the only thing left is to introduce 1/2 each term here. So finally we have 1/2, or sorry, that's 1/6. 1/2 times 1/3. 1/6 sine cube 2x minus 3 over 10 sine to the 5 2x plus 3 over 14 sine to the 7 2x minus 1 over 18 sine to the 9 2x plus c. So I will just put this inside the box, and then later on we will be comparing this with our answer on the previous technique. Okay, so again, this is done using the shortcut method, and let us compare it with the one we solved earlier by using the long method. Okay, so let's see if we got the same answer. So this is your 1/6 sine cube 2x minus 3 over 10 sine to the 5 2x plus 3 over 14 sine to the 7 2x, then minus 1 over 18 sine raised to 9 2x, and then of course plus c. Okay, so that's it for now, and for my next video I'll be working on the powers and products of sine and cosine functions, where m or n is an even integer. And of course, for our next video, we will be working on the group of tangent and secant function, and then the group of cotangent and cosecant function. So you just keep on tuning in on my YouTube channel to keep you updated on the related topics. So don't forget to like, share, and subscribe. Goodbye, everyone.